Hello, class. Today we're taking a look at the currents that we find in our ocean, and we're going to start by just going over the basics. We have ocean currents because the winds push the ocean current. Now, later we'll talk about all the different types of prevailing winds, but there are really two primary prevailing winds. The first one are the trade winds. So they're again, a wind is always named from the direction that it is blowing. So you have trade winds in the northern hemisphere are coming and they are blowing from the northeast, but they're blowing to the southwest. Trade winds in the southern hemisphere again are blowing from the southeast and they're blowing to the northwest. So the trade winds near the equator ultimately are taking the water and they're moving it from the east to the west. So again, those are trade winds. Now, if you can just imagine those trade winds, they are pushing water. The water is piling up over near the west sides of the ocean basin. And if you think about sort of what you do when you grab your water hose and you turn your water on, and then you put your finger over top of the end of that water hose, it's going to spray the water. It's going to make it go faster. Well, in the same idea, you've got a pressure gradient force over here. You've got water that's piled, and now that water is going to move quicker because of gravity squeezing it and making it move along that. And so that is called western intensification. Here's a picture sort of showing those pressure gradient lines. Here's my cursor. Here is the surface that is elevated because the water has pushed more water towards the west. And then once it gets sort of pushed together and a higher elevation, it moves out of that at a quicker velocity. And so those western sides have stronger currents and the eastern sides have weaker currents. And so we've got these boundaries, and the boundaries ultimately are formed by this moving water. And the next wind in the mid latitudes is pushing the water back in the opposite direction. So at 60 degrees north and 60 degrees south, the name of the wind are the westerlies. And so now we've got water that's sort of moving to the west near the equator, and then it gets and collides with continents. It gets moved sort of to the north, and then it gets taken back west by the prevailing wind called the westerlies. And so the westerlies are creating currents that are either on the northern side of our planet or on the southern side of our planet. And so those boundaries just are called northern boundaries and southern boundaries. So we're setting the stage here for a rotating current in the northern and the southern portions of every single ocean basin. The term to describe that moving water is called a gyre. So a gyre is a circle of ocean currents that sort of loop together. And there are four boundary currents that make up a gyre. And we've gone over some of them. The equatorial, again, is moving from the east towards the west. And then we have our western boundary current that is going to either move to the North Pole or to the South Pole along continents. And then you have your northern and your southern boundaries. And then you have, again, that southerly or back to the equator moving boundary called the eastern boundary. So again, even though we live on the west coast of the United States, we actually are on the east coast or the eastern boundary current, which actually is called the California current. Let's take a look at some of these currents. So just to review, let me show you the wind belts. Again, here are our trade winds, and they are going to be pushing those equatorial currents. And again, here are our westerlies in the northern hemisphere and the southern hemisphere, and they are going to be moving that to the west. So let's take off those, and let's take a look at our different currents. So let's take a look at the North Atlantic gyre. So again, there are four currents. You've got the equatorial current, and it's in the northern hemisphere. You've got the Gulf Stream. Now, the Gulf Stream is on the west side of the Atlantic, so it's a western boundary current. Then we have the North Atlantic Current, which again is a northern boundary current. And then we have the Canary Current, which is moving south. Now, just imagine this water moving across the equator. Every day it's getting warmer and warmer and warmer. So both the equatorial current and the Gulf Stream, which is a western boundary current, are warm water currents. Now, just imagine the North Atlantic Current. It's hanging out in the cold near Greenland. It's getting colder and colder and colder. So it transitions from a warm boundary, warm type of a current, into a cold current. Now, a couple of things that I want you to recognize, and when you're doing a homework assignment, we're going to be looking at creating statements, describe patterns, and we're going to use the word all. So, for example, if we look at in the Indian Ocean, in the Atlantic Ocean, and in the Pacific Ocean, all of the equatorial currents go from the east to the west. Now, if you take a look at all of the western boundary currents, they are all warm. The Gulf Stream, the Kuroshio, the Brazil, okay? And if you take a look at the rotation, all of the northern gyres rotate clockwise. All of the southern gyres rotate counterclockwise. That's just a little bit of an introduction to currents, and we can see some of them. The California current here, again, let's go over some of the characteristics of the California current. The California current, again, is an eastern boundary current. In addition to it being eastern boundary current, it's moving from sort of a polar region south, so it's a cold current. And what's interesting about cold currents is that they move relatively slow in comparison to a western boundary current. Again, because of western intensification, it moves quite rapidly. One last thing I'd like to show you is the idea of deep water circulation. We'll talk more about this in another video. But water that is moving in the deep is more dense because it's cold, and it's also going to occur in certain locations. So up here by the or up here by the Norwegian Sea and the Labrador Sea, that cold water sinks. It moves all the way south along the Atlantic, and then it comes into contact with this water that sort of formed near Antarctica. That water then can come up near the surface and follow a surface current back where it sinks here in the Arctic region, and it's sinking here in the Antarctic region. It also will move warm water, which also impacts climate, but it is a deep and salty current. So it's called a thermohaline current. Well, that's it for today. I hope you guys have a good day. Look forward to the next time we meet.